Audio and video both are clear now. Hi, good morning. Very good morning. Audio and video clear now. Just check it. Someone. Right. Okay. I think the live has started. It seems. Right. So this is a highway quick revision series we are doing. Right. Pavan. Good morning. Clear now. Started. So this is your highway quick revision session we are doing, right? Good morning, very good morning, very good morning. I think this is looking blur again, huh? Okay, one sec, let me change it. How it is now? Just check it. It is okay now. It's okay now, right? Okay. So this highway quick revision we'll be doing. So this is my profile. You can follow me at which, and what is that profile? rpcivilright.unacademy.com @/rpcivil, and this is the referral code you have to use, right? What is the referral code you have to use? rpcivil is the referral code you have to use, and these are all AIR 1 people, right? Those who got All India rank 1 from Unacademy, right, in various branches of engineering from GATE 2022 2024, right? Rishikesh, good morning. So all of you, tea, coffee, hot water, juice, breakfast, everything is over? Yeah, Ritu, good morning. Tea, coffee, hot water, juice, breakfast, everything is over or not over, all of you? Right. So this is Ummeed batch will be starting for which one? This GATE ESE PSUs 2025 on March 30th. Fluid mechanics will be started by Jaspal, or you can say. What is that? RP Civil is the code you have to use. In the description of this video, you can find all these links, everyone, if you just right. Sangram batch for this 2026 aspirants also will be starting on which one? This is March 30th only. So that is fluid mechanics by Jaspal sir will be starting, you can say. Okay. So now at present, this offer, tomorrow will be the last day for this offer to which one? This obtain this 1 year subscription at this 19,999. So that is 20,000. So after this, prices are going to be increased by this 30% everyone, right? So don't miss this opportunity. Inform to your friends, juniors and everybody, and ask them to subscribe. Okay. So this is placement batch also will be starting from 30th March for this 2025 aspirants. Now these are all the list of books you will be getting. Which one? For GATE Civil Engineering, when you are taking this iconic subscription, and they will be delivered to you within 15 days of your subscription, right? And if you feel that the amount is higher, you can go with which one? This is no cost EMI option, and that too with 0% interest on this EMI, all of you. Now these are all plus subscription features, and these are all which one? These iconic subscription features along with the plus features, you can say. Okay. Now these are all done, right? Yes, no? These are all done. If you just remember it, these are all chapters done now. And which chapter we are doing now? If you just observe that vertical alignment we are doing now. So no, horizontal alignment also gets completed or not, right? Horizontal alignment also gets completed, you can say, right? So which part we are doing now? You can say vertical alignment part we are doing now. If you just observe, right? The super elevation, equilibrium, command effect, right? Condition of vehicle on this curve. All these things are over now. Next, after that, extra widening we have discussed, right? After this extra widening is over, at that transition curve also we have discussed. Now, if you remember, curve resistance, setback distance, transition curve, right? Everything is over, right? Anything is left in this horizontal element? Nothing is left in this horizontal element, you can say, right? Yes, now nothing is left in this horizontal element if you just observe, right? Got it? So this is 108 point we have discussed, you can say. Okay. Now coming to this, right? This is lecture number 9 for this quick revision of this highway engineering. That is your vertical alignment part 1, you can say. Okay. Now along with this, I wanted to take 2 classes of this live test at some other time. So this will be going on in the morning at 7:45. At some other time at 2 p.m. or something like that, I want to take 1 hour of this one. Shall I take at 11 a.m.? Shall I take this at 11 a.m. if you just observe? Live test tomorrow or day after tomorrow I'll take at 11 a.m. Is that okay, everyone? No. In YT morning 7:45, morning YT 7:45, this quick revision will be going on. Every day quick revision only will be there, right? Okay, you have class. Okay. Yeah, okay. Sir, class is there for SSG, na? 2 p.m. Shall I take at 2 p.m. or 2:30 p.m.? 2 to 3. 2 to 3, 1 hour shall I take? Is that okay, Pawan? Right. Live test I will be taking. Right. This I will continue. Right. This will be there because I am supposed to complete 2 more special class hours for this month actually. Right. In app only. This will be there in YT continuously. This will be there in YT continuously. Daily. Daily will be there up to 31st March every day. But along with that, I wanted to take 2 special classes extra time. Right. Okay. One I will take on Sunday. One I will take tomorrow, day after tomorrow. Is that okay? Right. Now this is your chapter 10. Right. Quick revision of this highway engineering, that vertical alignment part 1 we are seeing, right? That is your chapter 10 gradients we'll see. Now 108 gets over now. Now we'll be going for which one? This 109. Okay, 109 you can say, right? Now here if you just observe what is the meaning of this gradient, what is the basic definition of this gradient, you can say if you just observe. What is the basic definition of this gradient, you can say? What is the basic definition of this gradient? If you wanted to go for this, right, first we have to understand what is the meaning of this gradient. Definitely, na? Yes or no? What is the basic definition of gradient? Tell me. What is the basic definition of gradient, all of you? Everyone. Hello? Someone? Vertical. Is it vertical or inclined profile? You can say gradient is nothing but. Gradients is nothing but your vertical, or it is an inclined profile if you just observe. It is your inclined profile, na? Yes, it is not the vertical, right? What is that gradient, you can say if you just observe? Gradient will be equal to, what are the symbols you will be giving for this gradient? Capital N is the symbol you can give, or capital G is the symbol you can give, or small g is the symbol you can give, right? Any symbol we can give it now, right? That is equal to which one? This is slope along length, right? Slope along which direction? Along this width direction or along this length direction, you can say. Slope along this length direction, na? Slope along this length direction, you can say. Or you can also call it as which one? Or you can also call it as which one? This is rate of rise or fall, right? Again, still it is showing like that only, that chumkis. Okay. Rate of rise or fall along length. Rate of rise or fall along length, right? Now it is okay, my face or chumkis are visible, that shining one, or it is okay. Rate of rise or fall along the length, right? Whenever it is rising, na, right? What is it you can say? Whenever it is rising, na, what is it you can say if you just observe? Positive or upward or ascending gradient, you call it as. Whenever it is falling, na, you call it as this falling or this downward or this descending gradient, you can say, right? So there are various names you can give for this if you just observe, right? Got it? Is not? Now here coming to this, no chumki, clear only? Okay, very good. Right. So here what is the minimum gradient? Tell me. There are various types of these gradients we are having. First of all, right, what is the minimum gradient? Tell me. Tea, coffee, hot water, juice, breakfast, everything is for all of you. For you. Minimum gradient will be how much? Tell me. It is taken as 0.5 percentage. 0.5 percentage means this 1 in 200, na? Is that no? Now you can also take it as this 1 percentage, that 1 percentage means this 1 in 100, na? 1 in 100, na? Is that no? So 0.5 percentage is for which one, you can say? If these are CC or whenever there is a lining provided, right? CC or this lined drains, okay? CC drains, or these are all which one? These are lined drains. So whenever lining is there, very lesser slope is also okay or not everyone? I think that looks like this only. Lining is there, right? Whenever that lining is there, that smooth surface will be possible. Whenever that smooth surface is possible, right? What is that you can say automatically? Whenever that smooth surface is there, right? What will happen? Tell me. Smooth surface is there means that smooth surface will allow the movement of this water easily, na? So higher slopes are required or lesser slope is also okay? Tell me. That lesser slope is also okay, na? Lesser slope is also okay, right? Is na? Lesser slope is also okay to take care of these, right? But whenever that earthen or these unlined drains are provided, earthen or this unlined, the surface is rough, right? Whenever this surface is rough, right, what happens if you just observe? Whenever that surface is rough, right, what happens? You can say water will not move easily, na? So water will not move easily, then how can you make the water to move? We can make the water to move by means of which one? This higher slope, you can say, if you just observe, right? Got it now? Clear? This is clear all of you, right? What is the purpose of this minimum gradient? That is mainly for this drainage purpose, na? Mainly for this drainage purpose, you can say. Got it? No. Second one, right? 111. Suppose if the gradient will be lesser than or equal to that ruling gradient, do you have any loss of engine power? That engine power loss will be zero, na? And that reduction in the speed also will be which one? This is zero, na? So engine power reduction and this speed reduction and both will be zero, na? Is or no? Speed reduction and this engine power reduction both will be zero, right? Is no? Now for gradient greater than or equal to that limiting gradient, right? What is the you can say? Delta P loss will be zero or will not be zero, right? Will not be zero. And speed change in the speed, that is reduction in the speed, is also not zero now. But these are higher extent or these are lesser losses you will be having, lesser amounts you will be having now. Is that no? Now suppose if the gradients are greater than or equal to that exceptional gradient, right? What is the you can say? That engine power loss rate, reduction in the engine power is not zero, and this reduction in the speed is also not zero, but these are more or lesser? Tell me. These are more reduction in the engine power and more reduction in the speed will be there now, obviously. More amount of this reduction of this engine power and more amount of this reduction of this speed, na? Isn't it? Is it clear? Is it lag? Is it lag for anyone? Others? Just check it. Once clear, now done. Once tell me this one, everyone. Okay, you are asking what is that LG? Limiting a gradient. Okay, LG is nothing but you are limiting a gradient, right? What is that RG? You can say RG is your ruling gradient. Okay, okay. I'm thinking any lag is happening, right? RG is your ruling gradient. LG will be which one? This is a limiting gradient. And what is that EG? If you just say EG is nothing but your which one? This is exceptional gradient, na? EG is nothing but your which one? This is exceptional gradient. If you just observe, right? Okay, note this and tell me. Clear everyone? This one. Right, once clear, note down. Once note, tell me everyone. Those who are maintaining the short notes and this itself will be sufficient, na? Done. Okay, very good. Now minimum gradient value we have seen, but other gradient values also we have to see, na? This is your first slide for today. 112. So what is the concept? We just observe there are various kinds of this terrains will be having, right? So what is the first and foremost one? You can say if it is your plain and rolling terrain. Next second one, what is that? You can say hilly and this is steep terrain, right? This is applicable for which one? This is a hilly as well as this is steep terrain. With what conditions? If you just observe, with the reduced level, right? Elevation is nothing but your reduced level only, no? Greater than 3000 meters, right? Reduced level is nothing but your elevation above the mean sea level only, or not, everyone? Reduced level is nothing but your elevation above the mean sea level only, right? Next, what is another one? Steep terrain, okay? This is your steep terrain with what conditions? If you just observe, steep terrain with this reduced level, what is that? You can say that reduced level is lesser than or equal to that 3000 meters, right? Reduced level is nothing but elevation above the mean sea level only, no? That itself, right? And now coming to this, we'll take the different values of this gradients, right? What are the different values of these gradients? You can say this is your ruling gradient. Next, limiting gradient. Next, what is that? You can say exceptional gradient. So what are the standard values we have to provide as per this IRC? Okay. Now what are these values? You can say ruling gradient will be what? 3.3 percentage. Limiting gradient 5 percentage. This exceptional gradient for this plane and rolling terrain 6.7 percentage. Okay. 6.7 percentage, right? Do you remember these values, everyone? Now, hilly and steep terrain with elevation greater than 3000 meters, what is it? You can say this is your 5 percentage, this is your 6 percentage, and this is your which one? This is 7 percentage, you can say, right? And this is your 6 percentage, this is 7 percentage, and this is your which one? This is 8 percentage, if you just observe, right? Now, 3.3 percentage means, right? What is it? You can say it is 1 in 30 na. Are this visible? That blue color, or shall I use some other? 1 in 30. 5 percentage means that 1 in 20 na. 6.7 percentage means that 1 in 15 or not? 1 in 15 you can say. So again 5 percentage is nothing but your 1 in 20. 6 percentage, 7 percentage rate, how much it comes to be? Tell me. 8 percentage is nothing but your 1 in 12.5 if you just observe. Okay. So what is that? 6 percentage means how much? 1 in 17. Okay, 1 in 16 or 1 in 17 you can make it now. 1 in 17 you can make it, right? So 7 percentage rate, what is it? You can say 100 by this 7, right? What is that? 100 by this 7 you come across if you just observe 14.28 now. So no, 1 by which one? This 14, right? 6 percentage is 1 in 17. Okay, 7 percentage is which one? This 1 in 14 you can say. Okay, these are the rounded off values if you just observe, right? But even if you don't remember, just to remember the percentages, it is sufficient enough. Yes, no? Now tell me, among these, which one, which gradient is dangerous? Tell me. Yeah, 14.28. 14.28. That is 6 is nothing but your 16.67. Okay, like that, rounded off to this 17 like that. Now, tell me, which gradient is more dangerous? Tell me. Ruling gradient, if you are providing this ruling gradient for any amount of length on the road, it does not matter, right? But why? Because there is no loss of this engine power, there is no reduction in the speed, no problem, right? But whenever it is this exception limiting gradient, right, what happens? You can say that limiting gradient, right, what will happen if you just observe? What is the meaning of this limiting gradient if you just observe? Limiting gradient is nothing but your less loss will be there. But exceptional gradient, if you just observe, exceptional gradient means it will be resulting in this less losses or more losses, you can say. More losses will be there. So now tell me, is it okay to provide this exceptional gradient for this higher length of this road? Right? So which one is not okay? Tell me. Which one is not okay? Tell me. Which one is not okay if you just observe? Which one is not okay? Exceptional gradient is not okay to be provided for this more length, na? Then what is that we need to do? We have to limit the length of this exceptional gradient, right? So length of exceptional gradient, right? What is the meaning of this length of road with exceptional gradient? Length of road with or length of road with exceptional gradient or length of exceptional gradient, both are same, right? It should not be greater than which one? It should not be greater than which one? 60 meters, right? It should not be greater than which one? This is 60 meters for which one? For 1 kilometer stretch, na? For a stretch of 1 kilometers, right? What is it you can say? For a stretch of which one? This 1 kilometers, if you just observe, right? And it should not be greater than which one? This 120 meters for what? For a stretch of which one? This is 2 kilometers, right? Now it is similarly, if it should not be greater than which one? This is 180 meters for which one? For a stretch of which one? This is 3 kilometers, if you just observe, right? Similarly, if you just observe, right, what is that you can say? It should not be greater than how many meters for this for a stretch of this 10 kilometers, if you just observe. For 10 kilometers, how much it should be? It should not be greater than this 600 meters, na? But is that entire 600 meters should be provided at a place, or we should not provide that entire 600 meters at a place? That entire 600 meters we should not provide at a place, na? That entire 600 meters should not be provided at a place, na? Listen, that entire 600 meters should not be provided at a place, right? Then what is that we need to do? That 600 meters we have to split into small parts, na? How much? It should not be greater than which one? This is 100 meters, right? Continuously. NUOUSLY. Continuously means at a stretch. At a stretch or continuously, maximum how much we have to provide? Exceptional gradient for maximum 100 meters length only we have to provide, na? Maximum 100 meters length only we have to provide, you can say PGSW, right? Isn't it? Got it now? Got it now? Right? Note this and tell me. Right? Yeah, Supriya, tell me. Previous slide, should I go for? Should not be more than 100 meters continuously, means at a place, right? Out of the 600, we have to split that 600 into different parts, okay? See, for 10 kilometer length of road is there, in that within that 10 kilometer length of road, exceptional gradient is allowed to provide for how much length? 600 meters maximum length. 500 meters, 600 meters maximum length we can provide. But that entire 600 meters length of exceptional gradient at a place we have to provide, or we have to split that 600 into chota bacha parts. We have to split that 600 into which one? This is chota parts, right? So each part should not be greater than which one? 100 meters, right? Each part, right? So should not be greater than 100 meters for which one? This each part. Okay, understood now? For each part, it should not be greater than which one? This 100 meters, right? Got it now? Clear? Understood, Supriya? Right. Now coming to this. Now, 114, right? What is it you can say? 114, right? Next one, exceptional gradient rate. We'll be having this one, right? Exceptional gradient rate. So what is the exceptional gradient conditions you can say? Exceptional gradient conditions, right? What is it you can say if you just observe? Length of exceptional gradient should be limited, right? Because if you provide this exceptional gradient for this more length, right, more loss of engine power will be there. Sometimes we may not be able to run our vehicles also, right? Yes, no? Sometimes we may not be able to run our vehicles also, right? What is it you can say now? Critical length of gradient. What is that critical length of gradient? Tell me. Critical length of this gradient CLG. So what is this critical length of gradient, everyone? It is your length of gradient, right? For which purpose? If you just observe, it is the length of gradient. Length of gradient is nothing but your length of road with that gradient, na? Yes, no? Length of gradient is nothing but length of road with that gradient, right? It is the length of gradient, right? What happens? You can say over which reduction of speed is considerable. When you can say it is considerable, it is by 25 kilometers per hour, right? If the speed is reduced by 25 kilometers per hour, na, then you can say that this much reduction will be considerable, you can say, right? Now tell me, this is your gradient, you can say. If you just observe what happens. So whenever you are entering onto this gradient, right, at this place, let us say 100 kilometers per hour. Now immediate, if it is a ruling gradient, no reduction in the speed, because ruling gradient will be maximum limit, right? Gradients will be lesser than that, we have to select it, right? No problem. But whenever it is a limiting gradient and this exceptional gradient, right, this kind of problem comes into picture, na? This kind of problem comes into picture, or not? Yes, this kind of problem comes into picture, you can say, right? Isn't it? Now here, what is that we are considering? This is 100 kmph, right? This is your 90 kmph, right? By the time when you are traveling to this point, right, what happens? It can be 80 kmph, right? By this time you are coming here, it will become this is 75 kmph, right? Now over this much length of this road, that speed is reduced by this 25 kmph, na? Over this much length of this road, that speed is reduced by this 75 kmph or not? Reduced by 25 kmph, na? Now this is your which one? This critical length of gradient for this value. Now suppose if I am taking this higher gradient, tell me, that portion is CLG. Yes, that portion is the CLG. If you are selecting which one is the higher length of the higher value, if you are selecting this higher value, if you are taking higher value, higher gradient or higher slope, right? What is that you can say? Whenever you are taking this higher gradient or this higher slope, do you require that much length, or within this smaller length itself, right? What happens? You can say that speed is reduced to 75 kmph. Within this smaller length itself, the speed is reduced to this 75 kmph. Na? This is your CLG. So this is your G1, and this is your which one? This is G2. So this is your CLG1 and this is your CLG2. Right? Got it? Now, right? So climb by ropes, right? If the gradient is very much higher, you cannot even enter also sometimes, right? You cannot even enter also sometimes, we can say, isn't it? You have to be careful, right? So higher gradient is there means over smaller length only will be reduced, na? Is no? Higher gradient means over this smaller length itself that speed is reduced by this 25 kmph. Lesser gradient means more length it will take to reduce the speed, na? Is no? Critical length of gradient for which one is higher? Tell me. Limiting gradient will be higher, or which one is higher? Tell me if you just observe. Exceptional gradient will be higher than the limiting gradient, and limiting gradient is higher than the ruling gradient, and the ruling gradient is higher than the minimum gradient. Now what is the you can say if you just observe? Critical length of gradient for exceptional gradient will be lesser than the critical length of gradient for which one? This is limiting gradient, because limiting gradient lesser value, lesser slope means it will take more length to reduce the speed by 25 kmph. Exceptional gradient is higher value, higher slope means it will over lesser length itself it will reduce the speed by this 25 kmph. Right? Got it? Clear now? Clear now, everyone? This one? What is the limiting length of this limiting critical length of this gradient, right? Everyone, is clear enough you? Clear? Now here what is that you can say if you just observe 115. Grade compensation, right? What is that a grade compensation? You can get it. Grade compensation, this is GC. What is it? You can say it is a percentage reduction of this gradient. Na? It is a percentage reduction of this gradient when associated with horizontal curve. Na? Just like that, we have to reduce a gradient every time, or when gradient is associated with the horizontal curve only, we have to reduce this gradient. Tell me, when associated with this horizontal curve, na? When associated with which one? This horizontal curve, right? When gradient is combined with the horizontal curve, then only we have to reduce it, na? Yes or no? When gradient is present, so this is your horizontal curve, right? What is this horizontal curve will create? Curve resistance will be there, na? Along with that, suppose if gradient is also there like this, right? What will happen? So this ring is moving downward now. In the same manner, even though you are applying some force, vehicle is moving in the backward direction. Means your vehicle is moving in the forward direction. What happens? You can say because of this gradient, grade resistance will be there, and because of this horizontal curve, curve resistance will be there, and both together, lot of resistance, lot of engine power loss will be there. Na? So to avoid that loss, we have to compensate something. Why? How to compensate? Increase in the radius is impossible. Only thing is we have to decrease the gradient, right? Either by filling this portion like this, or by cutting this portion, we can reduce the gradient value, right? Got it now? Why we are doing? To overcome this more amount of this loss only we are doing this now. In case of vertical curve, right? In case of this vertical curve, that gradient itself is a vertical curve. Huh? In case of this vertical curve, do you have any curve resistance? No curve resistance in case of this vertical curve, right? Do you have any engine power loss in case of this curve resistance? No. Gradient is there, upward gradient is there, that will create. Vertical curve is nothing but your gradient only, no. On this upward gradient, that loss will occur, okay? But on the downward gradient, no loss will occur, okay? So you have to be careful. Horizontal curve, right? What is it? Only gradient is present. Even vertical curve also you consider, only gradient is present, one loss only. But horizontal curve and gradient together are present. 1 plus 1 offer, double dhamaka na? Yes or no? Diwali offer. Isn't it? So whenever you are having this horizontal curve, curve resistance will be there. Vertical curve, horizontal curve, curve resistance will be there. Gradient also presented at the same time, right? Grade resistance will be there, right? Both resistances will be there, na? Yes or no? Both resistances will be there, right? Both resistances will be there, right? Both resistances will be there if you just right. So loss will be very much huge. To compensate that loss, what is that we need to do? To compensate that loss, what is that we need to do? To compensate that loss, right? What is that we need to do? Tell me. We need to compensate that loss, right? We need to reduce this gradient now, because increasing the radius to reduce the curve resistance is not possible. Only thing is decrease the gradient, so that little bit amount of this grade resistance will be decreased, and we can compensate that loss, right? Got it now? Understood? Now how can you get this grade resistance? If you just observe that grade compensation, that GC will be equal to 75 by R. Okay. Sorry, I'll write first one. 30 plus R by R, I'll write first. GC will be equal to 30 plus R by this R, and which one? 75 by this R. So which one we have to select? If you just observe, strictly speaking, that whichever is lesser, na? Whichever is less, right? Both formulas are okay, means that whichever is less we have to take, right? But when we have to use the first formula directly in the examination, instead of checking both, directly we can use the first formula if radius is lesser than or equal to 45 meters, right? When we have to use the second formula, if the radius is greater than or equal to that 45 meters, right, directly we can use the second formula, which will give lesser answer, right? So at 45 meters, both are giving the same answer, right? That a grade compensation will be getting it in the percentage, or we have to substitute in which units? Meters. Here also that r radius we have to substitute in which units, you can say meters. We just observe. Right, got it now? 116. Now after this compensation is over, right, what is that we need to do? You will be having the original gradient g as it is, or the gradient will be decreased? Tell me. You will be having this original gradient, or will be having this reduced gradient? Tell me. Will be having which one? This reduce na? Yes or no? What is that reduce means? Reduced gradient will come. After compensation, the gradient will be compensated gradient. After reduction, the gradient will be reduced gradient. Yes no? So now what is that next gradient you can have? Compensated gradient. Compensated, or this reduced, or which one? This maximum permissible gradient. Okay. So how can you get that compensated gradient? What is the compensated gradient? What is the compensated gradient? What is the compensated gradient? Tell me. Original gradient g minus which one? This grade compensation only, na? Yes. Original gradient g minus this amount of reduction, right? That amount of reduction is nothing but your grade compensation only, na? Yes or no? Right. Cg will be equal to that original gradient minus this grade compensation, right? So what is that we have to go for, right? This original gradient you have to substitute in percentage. Grade compensation also you substitute in percentage. Compensated gradient will be you will be getting in which one? This percentage answer, right? Yes, now is that clear? Right? Got it? Clear? Compensated gradient will be equal to that original gradient minus this grade compensation, na? Original gradient minus this grade compensation, right? Now next point. For gradients lesser than or equal to that 4 percentage, means gradients higher than 4 percentage or equal to 4 percentage. Gradients equal to 4 percentage or lesser than 4 percentage, right? For gradients lesser than or equal to that 4 percentage, right? What is that you can say if you just observe? As per IRC, no need to apply which one? This grade compensation, right? No need to apply what? No need to apply grade compensation, right? No need to apply this grade compensation, right? So that means what is it you can say? That means grade compensation will be equal to 0. Then what is the compensated gradient? It is equal to the original gradient, na? So no, original gradient, right? Isn't it? Right? Right? Clear? So now this is gradient will be grade compensation is equal to 0, means that compensated gradient will be equal to which one? This original gradient as it is, right? Original gradient as it is, right? So now along with that, compensated gradient should not be lesser than which one? This 4 percentage, right? Suppose if that gradient is greater than 4 percentage, and when gradient is greater than 4 percentage, that compensated gradient will be 0, or sorry, grade compensation will be 0, or grade compensation is not 0? Tell me. Gradient is greater than 4 percentage, compensated gradient is compensated gradient will be equal to 4 or not equal to 4? Tell me. Compensated grade compensation, grade compensation. If gradient is greater than 4 percentage, what is that grade compensation? That is reduction equal to 0 or not equal to 0? Not equal to 0. Then what we need to do? Not equal to 0 and compensated gradient lesser than 4. Then we have to take it as it is, or then modify this compensated gradient to which one? then modify this compensated gradient equal to which one? This is 4%, right? Understood now? Compensated gradient should not be lesser than 4%, means if it comes to be lesser than 4, you modify it to which one? This is 4%, right? Got it now? Got it now? Right? Not visible? Okay, modify, then modify, right? Then modify compensated gradient will be equal to which one? This 4%, right? I have written below. Now it is visible? Now it's okay? Now modify compensated gradient as which one? This 4%, right? That is what? Got it now? Clear? Right. Okay. Note this and tell me. Right, done? Shall I move to the next one? 118 point. After that, submit. Okay? So what is it? 118 you can say. Okay, Rishikesh, I'll wait, don't worry. Done? Right? Gradient is 5% now. Calculate which one this? Suppose, okay, this is, I am writing below this, you can say, right? Grade compensation is not 0 and CG is which one? This is greater than 4, greater than or equal to 4. No need to modify. Okay? No need to modify this CG. No need to modify this CG. Okay? Understood now, Pawan? Got it now? Clear? If compensated gradient calculated comes to be greater than or equal to from that condition itself, right? Original gradient is greater than 4. We have to apply which one? This. We have to apply which one? This. We have to apply this compensation compulsorily. But if it comes to be greater than or equal to 4, no need to modify this CG. But if it comes to be lesser than 4, then modify it to 4. Okay? Understood now? Clear? Understood now? Gradient is 5%, and based on this CG obtained, we have to decide whether it is modified or not. Okay, if the CG calculated comes to be lesser than 4, now modify it to 4. If it is greater than or equal to 4, now keep it as it is. Okay, understood? Clear now, everyone? Right, at this point and tell me, everyone. Okay. Yeah, minimum CG should be 4%, right? That is what you can say, just right. Okay. Clear? No. Gradient na, what is drainage? Gradient na. So the hydraulic gradient, right? What is the hydraulic gradient? For which purpose? To take care of what? To take care of this drainage when less camber, GH. Okay, G is the symbol you can give otherwise. When less camber is provided Why less camber is provided? Tell me. Less camber is provided with respect to which one? This comfortable traveling of this vehicle, na? Comfortable. For comfortable vehicle traveling, right? So higher camber will be resulting in which one? This comfortable vehicle traveling or uncomfortable vehicle traveling? Tell me. Higher camber will be resulting in this comfortable vehicle traveling or uncomfortable vehicle traveling? Very much higher camber will be resulting in which one? This uncomfortable vehicle traveling, na? So uncomfortable vehicle traveling, you can say. Now, so when you are providing a lesser camber, what is that you can say? Sorry, when you are providing higher camber, uncomfortable vehicle traveling, but drainage is good enough. Higher camber, drainage point of view, it is very good, right? Higher camber, drainage point of view, it is very good, but comfort point of view, comfortable traveling of this vehicle point of view, it is not good enough. Is it? No, it is not good, you can say. Then lesser camber, if you provide, vehicles will be comfortably traveling, but drainage will not be taken care, right? Then what is that we need to do? If we just observe how to take care of both, if we just observe, then how to take care of both if we just observe? But how to take care of this, you can say? By providing this lesser camber, right? You have to provide which one? This lesser camber you provide. You provide which one? This lesser camber, right? Whenever you are providing this lesser camber, more comfortable traveling of these vehicles automatically, right? When more comfortable traveling of these vehicles, what it will do? More comfortable traveling of vehicles, it is well and good for driver point of view, but drainage point of view, how can you take care? By providing higher gradient than the camber, na? Then that a gradient will take care of this camber, that G equal to that 2C. This is your hydraulic gradient, or C will be equal to that G by 2, right? Got it now, everyone? Is it clear now? Right? Hydraulic gradient, right? What is the hydraulic gradient, right? Now coming to this 119, that a resisting length of gradient. Resisting length of this gradient. Yes, both are same. Hydraulic gradient means the name itself is telling that it is mainly to take care of drainage. Okay, that is mainly for this drainage when camber is not comfortable for drainage. When camber is not suitable for this drainage, okay, this gradient will take care. Okay, resisting length of this gradient, right? What is the resisting length of this gradient? If you just observe, it is applicable for all gradients, or it is applicable for gradients greater than or equal to that floating gradient only, greater than floating gradient. So what is the meaning of this floating gradient? Tell me. Even without engine power also, right? What happens? Zero engine power you are applying, and your vehicle will be moving with the design speed, right? That is exactly the floating gradient. If the gradient is greater than the floating gradient, right, in the downward direction, what will happen? Even without engine power also, it will be zero engine power, it will be moving with more than design speed. So negative traction conditions. So with zero engine power, it is moving with very much higher speed, greater than the design speed, means in the upward direction of this, if you consider it, what will happen? First, vehicle cannot even enter onto this, even if you are using full engine power, na? Yes or no? So those kind of things we have to consider, right? Now, what is that L1? We can say that L1 will be equal to L0 plus which one? This is a H by F. Only there is only one book they have mentioned this criteria, that is Gupta and Gupta, right? There is no other book they have mentioned this criteria. Okay, that is the only book you can find where it is given. longitudinal friction coefficient. Here what is that L naught, you can say, if you just observe. This H is your level difference. More level difference between this first and the last point of this gradient, automatically what will happen? More resistance will be there, right? So it is directly proportional to H, right? Now whenever this friction is higher, this is moving in the backward direction because of this resistance, and friction will be acting in which direction? This forward direction, the coefficient of friction into that normal reaction and dash, like that. So more friction is there means it cannot move really in the backward direction, right? Means that friction is resisting the resistance of motion. Okay. Now this is your L naught original length. What happens? Whenever the gradient is very much higher, there is a possibility that your vehicle will come back up to this point also. No? So now this entire length will be taken as your resisting length L1. Okay. This entire length will be taken as your resisting length L1. Got it? Clear? This is the story of which one? This resisting length. Now what is the sign convention if you just observe for the gradients? What is the sign convention? Tell me if you just observe. Whenever it is that ascending or upward or rising, ascending or this upward or this rising gradient, right? What is it? We have to take it positive sign, right? Next, what is it? You can say descending or downward, or you can also call it as which one? This falling gradient. Then what is the sign we have to apply for this? Negative sign we have to apply for this. Okay, right. So this is the story of gradients, right? Vertical alignment, first chapter, gradients gets over. Okay, note this and tell me. Noted. Okay, noted. Clear now? Just within 1 hour, not even 1 hour. So just 40-45 minutes we have completed this gradient chapter. Right, na? That is the power of quick revision. Very quick revision, just within 10-15 minutes this gradient chapter gets over. Na? This is quick revision. Just before the examination, very quick revision also will do. Okay. Done? Rishikesh done? Yeah. Sign where we use means in that SSD calculations are we using the sign? It's an upward gradient positive is there, plus G plus N, downward gradient minus N we are using. Do you remember that? Upward gradient, downward gradient, right, like that, is not? And also in case of this net deflection angle calculations, right? Net deflection angle calculations also will be using which one? Net deflection angle calculations also will be using this positive and this negative sign, you can say. Okay, got it? This is your summit curve now. Okay, we'll be going for which one? Summit curve. That is chapter 11. Chapter 10 gets over. 6th slide. Summit curve. Okay, not visible. No? That is which point over? 120th point over, and this is your 121 point. So when you can call it as a vertical curve as a summit curve? A vertical curve is equal to, yes, right, that angle of deflection angle, or this net deflection angle, or this intersection gradient, right, all these things. A vertical curve is equal to summit curve if what conditions are satisfied? Tell me. This is formed by this two gradients combination, right? What is it? You can say this is your first gradient n1, this is your second gradient n2, right? What is this one? This is your PVI, point of vertical intersection, and this is your first tangent point T1, or this point of vertical curvature PVC or VPC. So this is how the summit curve will be there. And what is it? This is your second tangent point, or this STP, or this PVT, right? Point of vertical tangency. Now your vehicle is running like this. Now, okay. So what is that? If you just observe the first condition to be satisfied for this purpose, the first and foremost condition is what? That a point of vertical intersection is above the curve at its location or below the curve at its location. Point of vertical intersection is above the curve at its location. Point of vertical intersection is which one? Is above the curve at its location, right? So this point of vertical intersection is above the curve, definitely, right? Now convexity in the upward direction or convexity in the downward direction? Tell me. Convexity in the upward direction or convexity in the downward direction? Tell me. Convexity in this upward direction, na? Convexity in this upward direction, right? Next, what is the third most important point? Net deflection angle n is positive. That n must be equal to which one? Positive, na? Net deflection angle, or you can also call it as which one? This is net slope or intersectional gradient, na? So means what is that? You can say, if you just observe, this is your n or not? This is your n, you can say. Got it? Like the net deflection angle. So how can you get this net deflection angle? That a net deflection angle or this intersectional gradient or this net slope will be equal to which one? N equal to, first we have to go for which one? This n1 value minus which one? This n2 value. N1 value minus this n2 value we have to substitute, right? Then n1 how to substitute? Positive for this upward gradient, negative for which one? This downward gradient, right? This n2 also same, na? Positive for this upward gradient we have to substitute, and this is a negative for this downward gradient we have to substitute, now. Yes or no? Got it now? Clear? Note this and tell me. Done? Everyone done? Right? Okay. Now, so what are the different combinations of these gradients forming this summit curve? This is 122, na? Yeah, Rishikesh, tell me. Okay, shall I close then? Just I'll write this and I'll close it, right? At 9 o'clock episode class is there? Okay. Combination of these gradients forming summit curve. So what are the different combination of these gradients forming the summit curve? You consider that is your plus minus, okay? So means one upward gradient is meeting which one? A downward gradient, right? This is a summit curve definitely, na? This is summit curve definitely. But what is the net deflection angle? You can say that is your plus n1 value plus n2 value, no? So positive value. No. Second one, upward gradient is meeting a level ground, right? What is it? You can say this is your upward gradient n1 and meeting a level ground 0. This is your n1. What is that net deflection angle you will be getting? You can say that is your plus n1 will be getting, isn't it? Next, third one. What is that third one? 0 means level road, and this this is your level road, and this downward gradient. It's a level road and sorry, downward gradient. Sorry, it is reverse, no? One second. I'm saying level road, but I'm drawing downward. Okay. So it is which one? Ah, where it has gone? It is a level road and this is a downward gradient. Level road means 0 gradient and downward gradient is which one? This n2 gradient. Okay. Now this is also forming the summit curve only. What is the net deflection angle? You can say that is plus n2 only, that value. Now what is that another one? Two upward gradients, na? Two upward gradients, right? Two upward gradients with which condition? First gradient n1 is greater than this n2, na? So here this is your higher upward gradient n1 meeting which one? This lesser upward gradient, right? Both are forming this summit curve only, na, together. So what is the net deflection angle? You can get it if you just look at net deflection angle will be plus n1. So n1 is higher value positive sign, right? Minus n2. n2 is lesser value negative sign, higher value positive sign, so net value will be positive only, na? Like that. Next, last combination, two gradients of which one? These two downward gradients, right? So what are the two downward gradients? It is reverse, na? n1 is lesser than n2. Two upward gradients, n1 greater than n2 means two downward gradients, right? n1 is lesser than n2, then only it is possible or not? So lesser downward gradient is meeting a higher downward gradient. Right? This is your n2, this is your n1. So what is the net deflection angle? You can say it is your minus n1 plus this n2. No? So higher value n2 positive, lesser value n1 negative. So it is net value will be positive, right? Like that. This is the one. Okay, I'll be closing with this, right? Note this and tell me everyone. I'll close with this. Tomorrow again we'll continue. It's 7:45 AM only. Right, done? Everyone done? Any doubts anywhere? All of you? Any doubts anyone anywhere? Right. Thank you. Thank you all of you. Have a good day. Thank you.